Hello and welcome back to the Tech Blackboard. This is part 9 of DP203 exam Q&A series. So what are we learning today? Well, today we will focus on questions based on Azure Synapse Analytics, Azure Stream Analytics. We will also understand what is meant by slowly changing dimension and what are their different types. There will be also some questions on Azure Data Lake and Azure Cosmos DB. Interesting and equally important concepts are coming up, so sit tight, pay attention to the coming 15 questions in this part 9. Also, I would like to welcome the new members who have joined the Tech Blackboard in recent days, and for their benefit, a quick mention that we have already covered 100 questions so far in the previous 8 parts. All the questions are full of important concepts and supported by Microsoft documentation for further self-learning. The links for all the videos are available in the description box. Highly recommend to watch all of them. And friends, videos are great for learning online, but self-learning is equally important. And keeping that in mind, I will share a free PDF file containing all the 15 questions with answers covered in this part 9. And for that, you have to tell me the correct answers for the question number 101, 107 and 115. Answers to all the 3 questions are coming up in this video itself. And friends, if you find this video worthy of your time and an increment in your learning, please appreciate our efforts by pressing the like button, subscribing to the channel and press that bell icon to receive all the notifications of our upcoming videos. So let's get started. Let's begin part 9 with question number 101. The question says that you have an Azure Synapse Analytics database. Within this, you have a dimension table named stores that contains store information. There is a total of 263 stores nationwide. The store information is retrieved in more than half of the queries that are issued against this database. These queries include staff information per store, sales information per store, and finance information. You want to improve the query performance of these queries by configuring the table geometry of stores table, which is the appropriate table geometry to select for the stores table. Your options are round robin, non-clustered, or replicated table. The correct answer for this question is option C, replicated table. Now let's look at quick information on each of the option. So the round robin distribution is a table geometry that is useful to perform initial data loads. On the other hand, the non-clustered is not a valid table geometry in Azure Synapse Analytics. So keep this important point in mind. Then moving on to the replicated table, which is the correct answer for this question. So a replicated table is an appropriate table geometry choice as the size of the data in the table is less than 200 and the table will be replicated to every distribution node of the Azure Synapse Analytics to improve the performance. Moving on with question number 102, the question says what is the default port for connecting to an enterprise data warehouse in Azure Synapse Analytics? The options given are TCP port 1344, then we have UDP port 1433 and the last option is TCP port 1433. The correct answer is option C, TCP port 1433. And friends, as you all know, queries are integral part of DP203. So let's not forget the various questions that will appear on different kind of queries in DP203. Let's take 3 consecutive questions on different queries. And here comes question number 103. This says that you have the following Azure Stream Analytics and you have to give some true and false based on this query. Here you can see we have a query which starts with the with clause, and here you can see we have step 1 where we have selected input and partition it by state ID into 10. And then we have step 2 where we have selected the input 2 and partitioned it by state ID into 10. And then after this, what we are doing is we are selecting into output from step 1. Step 1 is this first with clause, and then we are partitioning it by state ID and we are creating a union with the step 2. Now based on this query, you have to answer these statements. The first statement is the query combines 2 streams of partition data. You have to tell whether it's a correct or an incorrect statement. The correct answer for the first statement is yes, it does combine two streams of partition data. Here you can see we have first stream as step 1 and the second stream is step 2. Also, please understand that you can now use new extension of Azure Stream Analytics SQL to specify the number of partitions of a stream when reshuffling the data. Moving on with the second statement, the statement says the stream scheme key and count must match the output scheme. The correct answer for this statement is also a yes. Looking at the explanation for the same, when joining two streams of data explicitly repartitioned, these streams must have same partition key and partition count. Now let's move on with the third statement, which says that providing 60 streaming units will optimize the performance of the query. This is also a yes or a correct statement. Looking at the explanation for this, streaming units represents the computing resource that are allocated to execute a stream analytics job. The higher number of SU or streaming units, the more CPU and more memory resources are allocated for your job. In general, the best practice is to start with 6 SUs for queries that do not use partition by. And here we can see we have 10 partitions. And where are the 10 partitions given in the query? This way. You can see into clause here in step 1 and step 2 as well. And that's why the formula becomes 10 partition or the number of partition multiplied by 6 streaming units. So we have now a figure which comes 6 multiplied 10 equals to 60 SU is good. And that's why we have chosen yes for the third statement. Now let's move on to question number 104, which is another query based question, and it says that you have a table in Azure Synapse Analytics dedicated SQL pool. The table was created using the following transact SQL statement. You can see there is a create table query, and what we are essentially doing in this query, we are creating a table which is a kind of dimension table named employee. And you can also observe various columns and their data type information given in the query. Then the question says that you need to alter the table to meet the following requirements. The first one is ensure that the users can identify the current manager of the employee. Then the second requirement is support creating an employee reporting hierarchy for your entire company. And then the third requirement is provide fast lookup of manager's attribute as name and job title. And then the question says which column should you add to the table. Your options are manager employee ID or manager employee key. The third option is manager employee key. However, this time the data type is different. We have now int. Earlier we had small int. And then the fourth option given is manager name, which is varchar. The correct answer for this question is option C, manager employee key, which has a data type as int. Now let's move on with one more question based on queries, question number 105, and it says that you need to implement a type 3 slowly changing dimension SCD for the product category data in an Azure Synapse Analytics dedicated SQL pool. You have a table that was created by using the following transact SQL statement. And here once again you can see we have a create table statement, and this time we are creating a dimension table called product. Then the question says that which two columns should you add to the table? Each correct answer presents part of the solution. And the options given are effective start date or current product category, effective end date, product category or original product category. Now friends, before answering this question, you must first understand what is the exact requirement of the question. Here the question is talking about type 3 slowly changing dimension. So let's first understand what is type 3 slowly changing dimension, and then we will come back to answer this question. So now I am on the Microsoft documentation, which will make you aware of various slowly changing dimensions. The first one is type 1 dimension. The second one is type 2 dimension. And then we have type 3 dimension, and that's exactly what we are looking for. So this one says that type 3 SCD supports two versions of a dimension member as separate column. Please pay attention. I will repeat this once again because on this very statement our answer depends. It says that type 3 SCD supports storing two versions of a dimension member as separate columns. And here you can also observe there is an example also given where Microsoft is giving you an example based on email information. Here you can see that we have current email and then we also have a column for original email. And that makes sense because as per definition, it says that it will be storing two versions of dimension member as a separate column. The knowledge that we gained from the Microsoft documentation, based on that, I can give you the answer as option B and option E. Why? Because in Microsoft documentation, we just saw that we need to maintain two versions of the dimension in separate two columns. So here we can see that we are maintaining the current product category and we are also maintaining original product category. So please pay very good attention when you're reading the question, whether it's a type 1, type 2, type 3, and in fact there is type 6 as well. The link for the documentation that I just referred is given in the description box. Things are just getting started. After that warm up on 3 query based questions, let's take some other type of questions. Here comes question number 106. The question says that you have a SQL pool in Azure Synapse. You plan to load the data from Azure Blob Storage to a staging table. Approximately 1 million rows of data will be loaded daily. The table will be truncated before each daily load. You need to create the staging table. The solution must minimize how long it takes to load the data to staging table. How should you configure the table? To answer, select the appropriate option in the answer area. Here you have to answer on 3 levels. The first one is distribution, the second level is indexing, and the third level is partitioning. And surely you can observe different options given for each one of them. Now let's look at the answer for each one of them. Coming to the distribution, the correct answer is hash. Then we are coming to the indexing. The correct answer is clustered column store. And then for the partitioning, the correct answer is date. Now let me give you quick logic for each of them. So hash distributed tables improve the query performance on large fact tables, and also understand they can have large number of rows and still they can achieve very high performance. So that's why we have chosen hash distribution, because we have large number of rows, which is 1 million. Coming to the indexing part, here we have chosen clustered column store. So you have to understand when you are creating partitions on clustered column store tables, it is important to consider how many rows belong to each partition. For optimal compression and performance of clustered column store tables, a minimum of 1 million rows per distribution and partition is needed. And that's exactly what also is given in our question. Then let's move on to the partitioning part. So here we have chosen date. The table partition enables you to divide the data into smaller groups of data, and in most cases the table partition are created on date column. So that's the reason we have chosen date as the partitioning option. So hopefully friends, this justifies the answers that we have chosen for this question. Now let's move on to a very interesting question, question number 107. And the question tells you that you have files and folder in Azure Data Lake Storage Gen 2 for an Azure Synapse workspace as shown in the following exhibit. You can see that you have one top folder. So this is your root, and under this root or top folder you have file1 CSV, and then you have couple of subfolders, folder 1 and folder 2. Inside these folders also you have some files, file 2 and file 3 respectively, and then you have one more file which is file 4, which is just directly under the top folder. Now the question further asks that you create an external table named ext table that has a location top folder. When you query ext table by using Azure Synapse Analytics serverless SQL pool, which files are returned? Your options are file 2 and file 3, file 1 and file 4, file 1, 2, 3, 4, all of them, or the last option is file 1 only. Now let's go to the Microsoft documentation and find out the correct answer for this question. So here I am on the Microsoft documentation that explains the use of external table with Synapse SQL. And on this documentation, you have to scroll a little bit down and you will reach to a section which says arguments create external table. Here you can see a very similar folder structure given by Microsoft. Let me zoom it if it helps a little more to you. Okay, so this is the folder structure, very similar to what we saw in our question as well. We have one root folder and here it is named as web data. Then we have mydata.txt and _hidden.txt. And these two files are directly under web data, which is the root folder. And then we have two subfolders which are named as month and hidden folder. And both these folders contains one file each. Now let's read the documentation carefully and find out the correct answer. The documentation says that unlike Hadoop external tables, native external tables do not return subfolders unless you specify / followed by 2 stars at the end of the path. In this example, if location web data, a serverless SQL pool query will return rows from mydata.txt, it won't return mydata2.txt and mydata3.txt because they are located in a subfolder. Now, taking the understanding from the documentation given by the Microsoft, the correct answer to this question is option B, file1.csv and file4.csv. Let's move on with question number 108. The question says that you have a table named sales fact in an enterprise data warehouse in Azure Synapse Analytics. Now, sales fact table contains sales data from the past 36 months and has the following characteristics. The first one is partitioned by month, contains 1 billion rows, has clustered column store indexes. Now the question says that beginning of each month, you need to remove the data from sales fact table that is older than 36 months as quickly as possible. Which 3 actions should you perform in sequence in a stored procedure? And here you can see we are given with 6 actions, and out of these 6 actions, we have to choose 3 of them and arrange them in correct sequence. So let's look at the correct actions in correct sequence. So the first action that you should perform is create an empty table named sales fact _ work that has the same schema as sales fact. Then as a second step, you should switch the partition containing the stale data from sales fact table to sales fact _ work. And then as a third step, you have to drop the sales fact _ work table. So those were the 3 actions in correct sequence. Moving on with question number 109, a similar kind of question. The question says that you develop data engineering solution for a company. A project requires analysis of real-time Twitter feeds. And now friends, the post that contains specific keywords must be stored and processed on Microsoft Azure and then displayed by using Microsoft Power BI. You need to implement the solution. Which 5 actions should you perform in sequence? As we did in the last question, out of these 7 steps, we have to choose 5 of them. So let's look at the first action. The first one is create an HD Insight cluster with Spark cluster type. The second one is create a Jupyter notebook. The third one is create a table. Then as a fourth step, you need to run a job that uses Spark streaming API to ingest data from Twitter. And then as a last 5th step, you have to load the HVAC table to Power BI desktop. So now let's check out question number 110, which is again a similar question. And the question says that you have an Azure SQL database named DB1 in East US 2 region. You need to build a secondary geo-replicated copy of DB1 in West US region on a new server. Which 3 actions should you perform in sequence? And down here, you are given with 5 actions. You have to pick any 3 of them in correct sequence. So let's look at the first action. From the geo-replication settings of DB1, select West US, and then secondly, you have to create a target server and select pricing tier. And then the third action would be that on secondary server, create logins that match SIDs on primary server. A quick snapshot for your reference. Whenever you will perform these steps, this is how it's gonna look. Friends, I'm sure that you're learning good with these questions. Just a quick reminder, please press the like button. And now let's take one more similar kind of question in question number 111. The question says that you need to create an Azure Cosmos DB account that will use encryption keys managed by your organization. Which 4 actions should you perform in sequence? And here you can see that we are again given with 5 actions, and out of these you have to select the 4 correct ones in correct sequence. The first in the sequence is coming up that you have to create an Azure Key Vault and enable purge protection. The second step that you need to take is to create a new Azure Cosmos DB account and then set the data encryption to customer managed key and enter the key URI. Post that, you have to add an Azure Key Vault access policy to grant permissions to Azure Cosmos DB principal. And then as the last step, you need to generate a new key in the Azure Key Vault. Now let's quickly jump to question number 112. The question says that you are planning the deployment of Azure Data Lake Storage Gen 2. You have the following two reports that will access the data lake. The first report, report 1, will read the 3 columns from a file that contains 50 columns. The second report, report 2, queries a single record based on a timestamp. You need to recommend in which format to store the data in data lake to support these reports. The solution must minimize the read times. What should you recommend for each report? To answer, select the appropriate options in the answer area. And please note that each correct selection is worth 1 point. So you have to give the answer for both report 1 and report 2. The options given are same for both the reports. We have Avro, CSV, Paraquet and TSV. And the correct answer for the first report, report 1, is Paraquet. And then the correct answer for report 2 is Avro. Now let's jump on to the question number 113. The question says that how long the recovery point objective of Azure Synapse Analytics? Is it 4 hours or 8 hours, 12 hours, or is it 16 hours? The correct answer of this question is option B, 8 hours. Moving on, we have question number 114. The question says that you have an enterprise data warehouse in Azure Synapse Analytics named DW1 on a server named server1. You need to verify whether the size of transaction log file for each distribution of DW1 is smaller than 160 GB. What should you do? And your options are on the master database, execute a query against the view given here. And then the second option is from Azure Monitor in Azure Portal, execute a query against the logs of DW1. And the third option is on DW1, execute a query against the sys.database files dynamic management view. As a fourth option, we have execute a query against the logs of DW1 by using getAZ operational inside search result PowerShell cmd-let. And the correct answer for this question is option A, that on master database, you have to execute a query against this dynamic management view. And with that, we reach to question number 115, which is the last question for part 9 today on DP203 exam Q&A series. Let's read the question. The question says that you have an enterprise data warehouse in Azure Synapse Analytics. You need to monitor the data warehouse to identify whether you must scale up to a higher service level to accommodate the current workloads. Which is the best metric to monitor? More than one answer choice may achieve the goal, and you have to select the best answer. And the options given are CPU percentage, DWU used, DW use percentage, and data IO percentage. And the correct answer for this question is option B, DWU used. And friends, if you want to read more on DW used, then this is the Microsoft documentation. And in this documentation, you have to scroll a little bit more and you will reach to a section which says resource utilization. And this section shows you all the metrics that are available in Azure portal for Synapse SQL. And here you can see we have CPU percentage, we also have data IO percentage, and similarly we have DWU unit, DWU percentage, and DWU used. I have given the link for this documentation in the description box. Please read through whenever you have some time. So friends, I hope you enjoyed today's session with 15 questions on some of the most important concepts related to DP203 certification exam. And if you learned something good today, please do not forget to like our videos, as each of your like help us to reach wider audience, and also do subscribe to the channel. Want to interact more with us? Then please join the Tech Blackboard on other social media platforms like Instagram, Facebook, and Twitter. Thank you so much for joining us and learning with us. I will see you in the next video. Till then, stay fit, keep learning, and thanks for watching.
If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you, and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning, and thanks for watching.